So my title today is Transforming Stadium Merchandising with Retailcloud, Harnessing Imply for Real-Time Analytics. So today I'm going to talk about who we are and talk about operational challenges in the stadium and our data architecture and challenges we faced while implementing our data architecture, and maybe sometime for Q&A. At Retailcloud, we provide cloud-based retail solutions specifically designed for sports entertainment industry. With our years of industry experience, we tailor our solutions to enhance fan engagement and streamline operations in the stadium. Also, we provide actionable insights. This allows business to make a data-driven decision in a smarter way. Our One Retail platform offers multiple supports for the retail business. This makes fan experience smoother and smarter. So the fan experience starts from where they check in at the entrance using our RFID kiosks or our cashier-assisted point-of-sale systems. We provide personalized marketing and pricing and loyalty programs based on the real-time data. And our platform integrates multiple shopping channels, and it provides a seamless shopping experience for the fans. And in-seat deliveries helps fans to order online and get it delivered when they enjoy the game. And we integrate with top fan loyalty providers in the market. And we provide CRM and fan engagement tools to have a relationship with the fans. And our RFID technology provides speed up the order preparation and dispatching process. And finally, we manage inventory is at right level for balancing stadium and online demands. This is our One Retail platform visual. So here you can see we provide point-of-sale systems, inventory management system, and integration with third-party APIs or even ERP platforms, including Oracle NetSuite, Oracle eBusiness Suite, and Great Plains, etc. And we integrate with top payment providers in the market, and we also support multiple business locations at venue in stadium. And we offer CRM and real-time analytics, employee management, staffing management in the stadium infrastructure. And we provide order management and also partner integration and solutions. So our platform is horizontally scalable, and we offer shared cloud, shared enterprise cloud, and also private cloud deployment for customers who opt in. And also we provide third-party integration tools as well. Those are built in-house. I'm happy to share we are proud partners of leading sports teams. I can name a few here, Lakers, Dodgers, Reds, and Yankees. There is a huge list. I can show very few here. And we built a point-of-sale system to support different hardware and platforms. So WinPOS, TabPOS, 6POS, these are different point-of-sale systems to work with different hardware platforms. And we provide Inventory 360 app, which helps to manage the inventory and label printing, and also console portal, which helps store admin to manage users, catalogs, orders, and multiple sales reports and dashboards. And we provide API tools, which helps our customers to directly integrate with our platform. So next, I'm going to briefly talk about stadium operational challenges. So in a typical stadium, especially during the big events, there are a lot of transactions happening in very short span of time. The high volume can overwhelm traditional systems, which often struggle to provide real-time insights to our merchandising managers. Without these quick insights, it becomes very difficult to make important decisions on the spot. Particularly, the merchandising managers have to make adjusting the staffing in the stadium during the high-profile events and adjusting the inventory and sales adjustments, and also they have to create promotions on the spot. So this is our architecture 1.0. So if you look at, there are 3 sections here: clients, our core platform, and our database layer. So our clients are point of sale systems, handheld devices, RFID reader, and reports and dashboards, which is built on the portal, and third-party API clients. Our platform is powered with microservice architecture. We have a handful of microservices running on our platform, and these services interact with our database layer. So we have a generic database, enterprise, these are shared database, and we have a dedicated MDB. One is nothing but merchant database 1, merchant database 2. So these are dedicated environments for customers who opt in. So the entire infrastructure is created in a dedicated environment for the customers who opt in for this. So this is our architecture 1.0, and some of the challenges I would like to highlight here. Our system could not provide, the architecture 1.0, immediate visibility into sales, which was leading to missed opportunities during the high traffic events. And complex SQL queries we were running to generate the reports and dashboards, which was slow because of the complex SQL join queries, and it was delaying the critical decision in the fast-paced environments. And our OLTP database struggled to handle transaction volumes during the major sporting events, which was causing delays in the data processing. The tightly coupled architecture that I showed you in the previous slide restricted the ability to integrate new tools into our platform, which was making it difficult to adapt the growing demands. An operational inefficiency where the merchandisers lacked real-time data on inventory levels and sales performance, which was leading to overstocking the items or missed restocking opportunities. So to overcome this problem, we started exploring data analytics platform, where we can have a platform which can help us to do all this real-time stuff. When we started this platform, our mission statement was we wanted to revolutionize stadium merchandising by providing real-time analytics. That should empower the merchandiser to make a data-driven decision during the high-profile events. Our key focus area at the time was optimize sales and inventory level with instant information, and based on that, the merchandisers should be able to make actionable insights and enhance the fan experience through agile and efficient operations, and enable merchandisers to stay responsive in a high-profile events. So there are many use cases. I'm going to briefly discuss about one of the use case, which we call it as player-specific merchandising boost. So let's say during a baseball game, one of the player, let's say Ohtani, has a standout performance. He is making a excitement among the fans. When this happens, generally in a stadium, the jerseys of that player will rapidly sell out. So when this happens, our POS system should be able to track the spike on the jersey sales and push this information to our platform. Our platform should be able to process this data and send out in real time and send out alerts to the merchandising managers. The next step would be for merchandising managers to do an actionable decision. The one is restock on the fly. The managers should be able to quickly restock the player's jersey where there is a low inventory level on the stands in the stadium. And also, they would like to push a notification to the fans saying, hey, there will be a 10% discount for next 10 minutes on this player's merchandise or the jersey. So if the merchandise manager wanted to make a real-time decision, then everything should be fall in place. The results, the managers prevented the missed sales opportunities by efficiently restocking the items on low inventory stands. And they have capitalized the emotional moment of the game, and also they were able to drive the fan engagement, and they were able to boost the sales. So this is one of the use case we were thinking about it. How can we get to this level? So we set a key goals when we started this platform. Our platform should be able to process millions of transactions in the short period of time. And the platform should be able to offer sub-second query performance on the dashboards. And the architecture should be decoupled so that we can use any external tools to pull the data out from our platform, and we can create a different visualization based on the customer needs. And we should be able to stream the data real time to the platform. And platform should be able to scale to millions of records. We don't want to really play with all the archival on our OLTP database. If the system is capable of handling it, we are happy, and we can go back and look at all the history. And the platform should be able to offer running complex queries to run the different reports. And we were looking for good technical support if you opt in for any paid solution. And finally, the solution should be cost effective. At that point, we were not ready to spend millions of dollars. Okay, how did we approach this? We researched a handful of technologies, and we shortlisted few. Then we started working on a POC. So in the POC, we wanted to show how streaming works. Are we able to load large amount of data? So we shortlisted Imply, drew it. Can we load large amount of data, and can we visualize it? And validate the POC against our goals. And are we able to successfully integrate with our existing platform? And work closely with the Imply support team to solve any problem if we come across. And finally, implementation. So we were able to successfully do the POC with help of Imply team. This is how our architecture evolved. So if you look at it, we were on architecture 1.0, and we were able to easily extend it to architecture 2.0. So we have added extra layer, which is DAP, Data Analytics Platform, and we added on the layer on the right side, you can see Kafka for real-time streaming, and we were using Confluent. We didn't spin up our own infrastructure for Kafka, and also you can see enrichment service and Imply Druid. So the transactions from our point of sale system are getting pushed into our existing platform, and our existing platform records the transaction into our database, our OLTP database. At the same time, the transaction is streamed into Kafka. In Kafka, we had two categories of topics. One is incoming topics, second one is enriched topic. The enrichment service that we built natively, which enriches the incoming topic information and pushes into the enriched topic. And we had a Kafka connector in Imply. The Kafka connector was able to pull the data to Imply. And finally, we had an analytics service and sales analytics service. These services were able to pull the data directly from Imply and push it back to our dashboards. So this enabled us to get the performance that we wanted. So let me move on next one. So for data ingestion to Imply Druid, we have used two connectors. Kafka connector, this is mainly for the real-time streaming. So there are two category of elements coming into the Kafka. The one is sales transaction. The other one is the product catalog items. So whenever somebody goes and makes changes on our platform, let's say somebody changes the price of the product or name of the product, that update will flow to Kafka, and then it goes to Imply. So this is handled through the Kafka connector, and also the inventory information or levels are getting pushed into Kafka and then Imply. And then we used file connector, which is mainly used to backfill the customer data. So let's say we had a customer over the last 3 years. We wanted to push all the data into Imply. So that's where we used file connector. There is another use case where used was we periodically compare OLTP and Imply database. And if you find any mismatches or missing data, then we created an ingestion task, which takes care of pushing this information to Imply. So a lot of things were out of box in Imply. We didn't have to really write a lot of code to achieve this. And especially with file connector, the benefits we saw was low overhead on processing a large data set, especially when we had to upload 3 years of data to Imply. Just put it in a file and dump it, and Imply takes care of it. And it was easy to set it up. So also, another good thing is no Kafka usage. So we were running through Confluent. We didn't want to really use Kafka credits by processing a large amount of data. So I felt it was just cost effective. So we didn't stop there. So now if you look at this one, so far we talked about how we process our internal data, which is coming to our platform. But now we have another use case where we wanted to get the data from external systems, especially in the sports industry. A lot of things will change based on the different conditions. So like weather, which can impact the game performance and sales, and game data and game statistics, ticket sales or attendance, and live media information. So these information we need to be in our system so that we can enrich it and we can make it different dashboards and different decisions. So we bring this data to our system, we keep it in our entertainment DB, and then we enrich it and we push it to Imply. So now Imply has external data, enriched external data, and all our sales data. By using that, we can create different visualizations. So we built a Streamboard, which is our visualization platform, where customers can get all the internal data and external data, and they can create different dashboards. And also, our AI initiative brings this data to our GenAI platform, where we can create different forecasting and predictions, etc. So this visualization platform is a self-service by customers. They can go and build their own dashboards. So results, reports, and dashboards are now powered by Imply. And what we saw was the reporting response time improved by 10x. And we were able to enrich the external data and make meaningful decisions. So now our customers are able to make quick decisions to boost their sales. Okay, it didn't stop there. There is more to go. So I'm going to talk about one more use case. So i360 RFID, which is our inventory management system. So which is a simple handheld device. You can see it on the picture. So by using this device, you can go to warehouse and you can scan the items and check the inventory. So typically, this is involved by a lot of manual and tedious work. So if each item is label printed with RFID, then it is much easier to just scan the items. So this device is able to handle or scan 5,000 items in a minute. So let's think about if there are 10 people are working in a warehouse. So almost 50,000 items can be scanned, and you can generate the inventory levels, inventory reports quickly. The scanned items, by using this device, are pushed into our platform, then it goes to Imply. And then from Imply, we pull the item and we show the inventory levels in the dashboards. So I cannot imagine how can we do this just with OLTP database without Druid and Imply. So this gives us 98% inventory accuracy and 40% operational efficiency and 30% cost reduction. This is a quick demo how this device is used and how the data is pushed. So this is a warehouse. The device is scanning the items, and it's counting it and is pushing the data to Imply immediately. So once these items are scanned, we can see the number of items scanned on the device itself, as well as on the dashboards, which is available on our portal website. So the warehouse manager can sit somewhere. He can, on live, he can see the number of items getting scanned and what is the inventory level. So you can see the number of items scanned on the screen. So with that, I'm inviting Jamshid to talk about challenges we faced on the implementation.
So when you started, we were in a traditional database background. And when we started discussing with the Imply team, and we wanted to understand how Imply works internally, it's a time series data, and that's totally different from what we have already done. So there are a lot of query options internally inbuilt, and we can utilize that, but we were not aware of how, on which situation we can use that. So we had a lot of discussion with Imply. I believe at the very beginning, Joe was helping us to make that mindset shift from traditional to time series and approach the solution that way. And when we started implementing it, one of the other challenge we have faced was, in the system, it allows modifications of data in multiple areas. Sometimes the catalog details will get duplicated, and some update will happen, and some critical updates will be happening to the transactions as well. And this was actually creating a duplicate in the system. So we want to get rid of the duplicates in order to provide the better analytics. It's not a lot, but the problem was sometimes some people purchase a lot of high dollar value items, and the transaction value was a huge one. Sometimes a lot of products will be purchased, and the number of units will be different. So since we are pushing the data real time, that will change the decision, and the numbers were a little coming off. So the first approach we have tried to solve was to utilize the latest by functionality in Imply, which was, it's not directly fetching the data from the table. Instead, you make a subquery and you take the latest records, and it will give you the latest records without any duplicates. But there was a problem because subquery was not a good solution for us. When we utilize the subqueries in order to fetch data, the performance was not as expected. And there was some limitation on the Imply. It is based on your cluster size and project size. Based on that, there's a limitation on that. And the data we wanted to process in that period was not coming within that limit. So it was some kind of block in that process. And we had discussion with the Imply team. They supported us very well. They gone through the architecture, and we tried to understand how we can fit into a different solution in place. And what we have done is, the next slide. So how did we solve this problem? So we understand that the way initially we approached it was some problems was there, and we have to change that mindset, and we have to re-architecture a little bit on the data side so that we can reduce the usage of subqueries and we can minimize the occurrence of duplicates. And we did that, and the next option was to replace the data which is coming as a duplicate. So anyway, when we modify data, there will be a duplicate because we are not supporting upside yet. And how to get rid of that? That was the replacement option. So in Imply, we have a replacement functionality. So you can, if you find a problem in a specific area, you can replace the data with the clean data. And Imply is pretty good in that case because without affecting any of the top level data, it replaces, clean the data, and put it back. And it won't affect any of your data. So we gone with that solution, and that really worked very well. And we were talking to Mark. Mark helped us to fine-tune the solution, as well as Jyoti. So throughout this process, anytime we faced challenges, the support was just like Imply. The support also, it was real time. So whenever we want some help, we just message them. Instantly, they reply back, and if we are really blocked, and they'll get into the call. So without Imply support, definitely we can say that we won't be able to come to this level. Thanks to everyone. Paul was making sure that we are not lost. And of course, as I think whoever using Imply, we are also waiting for the upsert functionality. Hopefully, it will be coming soon. And once it is there, we are ready to test it in production itself. Okay. Thanks, everyone. That's the challenges and how did we solve that. Thank you.
Just to conclude, so far we are happy with our implementation, and we were able to successfully leverage Kafka and Imply Druid to build our data analytics platform. Our customers have started using it, and we have been receiving feedback, and we are continue to innovate and continue to extend our platform to address most of other use cases customers are bringing into our table. And thanks to Imply, as Jamshid said, Daniel, Paul, Satvik, and Mark, Jyoti, they have helped a lot, and they are continuously helping us to unblock us. Thanks to everyone.